One small step for man, one giant leap for mankind.
After more than 50 years, humanity is on the brink of returning to the moon. This time, with the innovative partnership of NASA and SpaceX, the mission extends beyond planting flags and leaving footprints. The goal is far more ambitious: to establish a permanent base on the lunar surface. What makes this mission even more remarkable is that SpaceX intends to accomplish it using only its Starship vehicle. Not only will Starship transport astronauts to the moon, but it will also play a central role in constructing and supporting the lunar base itself. How will SpaceX bring this bold vision to life? Join me on today's episode to find out, only on Great SpaceX. In a presentation at Starbase, Texas, Elon Musk, the founder of SpaceX, outlined the company's ultimate ambition, Moonbase Alpha. This lunar base will be built using the Starship spacecraft, specifically the Human Landing System variant. The Starship HLS is designed to ferry astronauts between lunar orbit and the moon's surface and back again. Developed as part of NASA's Artemis program under the Human Landing System contract, Starship HLS plays a pivotal role in NASA's mission to land a crew on the moon. Like its standard counterpart, the Starship HLS is 50 to 60 meters tall with a 9-meter diameter and can transport more than 100 tons to the lunar surface. Equipped with 6 Raptor engines, the HLS variant will utilize these powerful engines during launch, landing, and ascent phases. However, the HLS differs significantly from the standard Starship in several ways. Since it does not re-enter Earth's atmosphere, the heat shield and flight control surfaces typical of Starship are removed. This modification reduces mass, decreasing the number of refueling tanker launches required once the spacecraft reaches orbit. Additionally, without the need for re-entry systems, the methane and liquid oxygen tanks can be repurposed for other functions once the spacecraft is on the moon. Another key feature of the lunar Starship is its white exterior, replacing the iconic stainless steel design. This change enhances thermal management, crucial for surviving the extreme conditions of the lunar environment. Building the lunar landing system from an existing Starship design rather than developing a completely new system offers many advantages. NASA has emphasized that minimizing changes to the vehicle configuration and standardizing the design for the HLS will streamline development. This approach eliminates the need for redundant testing, evaluation, and verification processes required for entirely new designs. By doing so, SpaceX can accelerate production timelines, ensuring the spacecraft is available for mission integration and deployment on schedule. With these groundbreaking adaptations, SpaceX and NASA are at the starting line in order to make history by not just visiting the moon, but establishing a lasting presence there. Then again, NASA may not yet fully appreciate the unique advantages of building a lunar habitat from SpaceX's Starship, particularly its transformation into a permanent base after serving as a lunar landing system. This ambitious concept utilizes the vehicle's entire internal volume, including its fuel tanks, to create a habitable environment. Here's how this transformation can be achieved and the innovative process behind it. Establishing a permanent lunar base demands significant infrastructure, equipment, and essential supplies for astronauts to conduct research and sustain long-term habitation. To achieve this, SpaceX proposes launching 2 Starships to the moon. One will carry astronauts, while the other, an unmanned craft, will transport supplies. The supply Starship will be loaded with tools, materials, systems, and provisions necessary for building and maintaining the base. Before departing Earth's orbit, both vehicles will undergo refueling in preparation for the trans-lunar injection burn. The designated landing site is the Shackleton crater at the moon's south pole. This site is ideal for a permanent lunar base due to its unique conditions. The peaks along the crater's rim receive nearly continuous sunlight, a critical feature for solar power generation. Meanwhile, the crater's interior remains in perpetual shadow, making it a potential reservoir for water ice, essential for sustaining life and generating fuel. Shackleton also offers a direct line of sight to Earth, facilitating uninterrupted communication. These advantages make it a prime location for lunar habitation. Upon landing, astronauts will descend to the surface using Starship's elevator system. Their initial tasks will include remotely deploying power reactors, solar panels, and radiators, as well as transferring any remaining fuel into designated storage tanks. Once these preparatory steps are completed, the process of transforming Starship into a lunar base can begin. The transformation process relies heavily on robotic assistance to minimize astronaut exposure to the Moon's harsh environment. Cosmic radiation, extreme temperatures, and limited mobility in extravehicular activity suits pose significant challenges. Therefore, remotely operated robots will handle most construction tasks, ensuring efficiency and safety. The first major step involves positioning the Starship horizontally. This requires reducing stresses on the vehicle's body by unloading any non-essential payloads such as radiators and solar panels. These systems can be deployed outside the vehicle, reducing its mass and lowering its center of gravity. The internal volume of the tanks and payload area will be kept at minimal pressure to maintain structural integrity during the maneuver. The horizontalization process utilizes a hinge mechanism to guide the vehicle's tilt. Elevator cables will detach and anchor to support the vehicle's weight during the initial phase, while a scissor lift will transfer the load to the ground in the final stages. The vehicle will ultimately rest between two parallel ridges of piled regolith, preventing rolling and providing structural support. With the Starship positioned horizontally, the next step is to empty its fuel tanks completely. Residual fuel is vented to eliminate any risk of fire during subsequent modifications. These empty tanks, along with the cargo bay, form the foundation for the habitable areas of the base. Remarkably, converting the fuel tanks alone creates a space approximately 2.5 times larger than the International Space Station's habitable volume. After cleaning the tanks to remove any remnants of fuel, construction begins with the installation of insulation and radiation shielding along the internal walls. Floors are then added to the structure, which can either feature a single expansive level with high ceilings or multiple levels nearly 3 meters high each. These design options prioritize comfort and aim to reduce the psychological stress of living in a confined space. The interior is divided into functional areas to support the astronauts' daily needs and scientific objectives. These include private and communal living quarters, complete with sleeping pods, a kitchen, and a lounge area. Scientific facilities will include a laboratory for experiments, such as growing plants without soil to establish sustainable food sources. Additionally, a small medical bay equipped for treating injuries and illnesses will be installed. Finally, cables and pipes will be laid for essential systems such as communication, electricity, ventilation, and water distribution. Despite the extensive modifications to the Starship's interior, an additional protective measure is necessary, which involves covering the base with a layer of moon rock. This is crucial for shielding against meteoroids, which pose a significant threat on the moon due to the lack of an atmosphere. On Earth, meteoroids typically burn up in the atmosphere before reaching the surface, but the moon's exposure makes it vulnerable to high-speed impacts. A 5-meter thick layer of regolith, the loose soil covering much of the lunar surface, will be applied over the base. This protective shell not only guards against meteoroid strikes, but also provides additional insulation. This innovative approach transforms the Starship HLS into a permanent lunar habitat capable of supporting long-term missions and advancing humanity's exploration of the moon. By repurposing the vehicle, SpaceX maximizes its utility, turning what would have been a single-use lander into a sustainable base. The process is efficient, cost-effective, and aligns with the overarching goals of establishing a human presence beyond Earth. Once operational, the base will provide a platform for scientific discovery, technological innovation, and preparation for future missions to Mars and beyond. Its location at the moon's south pole offers unparalleled opportunities for studying lunar geology, harvesting resources, and testing life support systems in a real-world extraterrestrial environment. Furthermore, the base could serve as a stepping stone for deeper space exploration, reinforcing humanity's position as an interplanetary species. In conclusion, the transformation of Starship into a lunar base represents a groundbreaking step in space exploration. This dual-purpose vehicle not only fulfills its role as a lunar lander, but also evolves into a habitable structure, pushing the boundaries of what is possible in off-world construction and sustainability. By leveraging innovative design and robotic assistance, SpaceX is poised to redefine humanity's relationship with the moon, laying the groundwork for a future where permanent lunar habitation is a reality. Of course, in order to survive in the moon in the long term, humanity must first address the fundamental necessities: air, water, and food. The moon's atmosphere contains no oxygen, but the lunar surface is covered with a layer of sand-like material composed of metals and oxygen-rich compounds. While we typically associate oxygen with the air we breathe, significant amounts are trapped within the moon's regolith. Extracting oxygen from this material could provide astronauts with a sustainable supply of breathable air for future missions. Impressively, just 20 grams of lunar soil contains enough oxygen to keep an astronaut alive for about 20 minutes. NASA recently demonstrated the feasibility of this process at the Johnson Space Center in Houston, where scientists successfully extracted oxygen from simulated lunar soil. This test validated the potential to harness oxygen directly from the moon's resources, offering a vital lifeline for human survival and even fueling future space exploration missions. While water is scarcer on the moon than on Earth, it is present, particularly in the form of ice. The lunar South Pole, where future settlements are planned, holds the highest potential for discovering ice deposits. This water will serve multiple purposes, supporting human life, enabling food production, and contributing to propulsion technology. Water will be essential for growing crops on the moon, a critical step toward establishing a sustainable food source. After purification, water can be used for drinking and daily activities, eliminating the need for astronauts to consume recycled urine as they currently do. Beyond sustaining humans, water can also be split into hydrogen and oxygen through electrolysis. The resulting hydrogen and oxygen can then be stored as liquid propellants for a rocket engine. This capability positions the moon as a potential refueling station for missions venturing further into the solar system. Energy is another key factor for lunar sustainability, and helium-3 extraction may provide an innovative solution. Helium-3, a light and sustainable isotope of helium with 2 protons and 1 neutron, has long been considered a promising energy source for nuclear fusion. Unlike conventional nuclear reactions, helium-3 fusion produces minimal radioactive waste, making it an attractive option for clean energy. The moon's regolith contains significantly higher concentrations of helium-3 than Earth, thanks to billions of years of deposition by the solar wind. If successfully harvested, helium-3 could fuel fusion reactors, offering a sustainable and efficient energy source to power lunar bases and possibly even future Earth-based systems. Communication will also play a pivotal role in establishing a lunar base, and SpaceX's Starlink system is poised to address this challenge. Laser communication technology, which NASA has been testing since 2013, has demonstrated the ability to transmit data at record-breaking speeds between Earth and the Moon. SpaceX has integrated optical space lasers into its Starlink satellites, enabling data transmission rates of up to 200 gigabits per second. This innovation allows Starlink to create a space-based mesh network that connects remote ground locations and spacecraft without requiring nearby base stations. For example, during the Polaris Dawn mission, Starlink successfully provided high-speed internet connectivity to SpaceX's Dragon spacecraft. This capability means that Starlink could establish an expansive communication network linking Earth, the Moon, Mars, and spacecraft in transit. By leveraging this infrastructure, distant outposts and missions would benefit from seamless data transfer and communication, supporting both operational needs and real-time coordination. The establishment of a lunar base is only the first step in a much broader vision. The ultimate goal is to transform the Moon into a thriving outpost that serves as a launchpad for deeper space exploration. This mission isn't merely a race for national pride or technological supremacy. It's a pivotal milestone in humanity's evolution as a spacefaring species. Through the extraction of oxygen and water, the development of advanced energy sources like helium-3, and the implementation of cutting-edge communication networks like Starlink, humanity is laying the groundwork for sustainable living beyond Earth. Each advancement brings us closer to realizing a future where the moon is not just a stepping stone, but a cornerstone in our journey towards the stars. Starship is achieving extraordinary milestones, paving the way for SpaceX to focus on future goals. Among these objectives is addressing how astronauts will live during their journeys in space. To explore this question, we step inside Starship, where a utopian vision of life in space is beginning to take shape. Just how incredible is the space inside Starship? We are witnessing Starship, a pioneering rocket system shaping the future of space exploration, making extraordinary strides. These include controlled vertical landings, initial catches using the Megazilla arm, and more groundbreaking achievements. With this momentum, Elon Musk has set bold goals, launching the first crewed mission to Mars within the next 4 years and returning humans to the moon for the first time in over half a century within the next 2 years. These ambitious milestones underscore the critical importance of building a crewed version of Starship. Recently, a rare glimpse into the interior of Starship revealed its current state, a stark, primitive space featuring stainless steel walls lined with pipes. The challenge of transforming such a space into a habitable environment for astronauts is immense, but many innovative ideas have been proposed. Among them, the concept of a 6-floor design stands out, showcasing how the payload compartment would be optimized into an unprecedented system for living and working in space. This visionary design divides the interior into 6 distinct floors, each dedicated to a specific function. Starting from the lowest level, this area would serve as a warehouse storing cargo, payloads, vehicles, and essential equipment for both life on board and scientific research. It would also house the power control systems that supply energy to the spacecraft. Locating these functions on the lowest floor is both practical and efficient, given its proximity to the spacecraft's fuel tanks. This placement minimizes the impact on the crew's living areas while facilitating seamless integration of the spacecraft's systems. The second floor would focus on sustaining life through agriculture, functioning as a miniature farm. This space could be used to grow crops and store food supplies, providing fresh produce to enhance the crew's meals during extended missions. Tending to plants could also serve as a calming and morale-boosting activity for astronauts. A dining area would likely be included here, consolidating food-related activities into a single efficient space. Physical health would take center stage on the third floor, which would feature an exercise area equipped with machines similar to those found on Earth. Maintaining cardiovascular health, muscle strength, and mobility in a microgravity environment is crucial for astronauts, and this space would ensure they have the necessary tools to stay fit. Bathrooms and toilets might also be conveniently located here, as this floor would see frequent activity. The fourth floor would provide private sleeping quarters, arranged in a circular layout. These rooms would be spacious enough to ensure comfort and privacy, offering astronauts a personal retreat for rest and relaxation. Above the sleeping area, the fifth floor would serve as the main communal living space. This expansive area could accommodate research activities, meetings, and leisurely pursuits. A standout feature of this level would be a large window system, offering breathtaking views of outer space and fostering a tangible sense of exploration and adventure. Finally, the top floor, situated near Starship's header tanks, would house the central control area. This critical workspace would manage the spacecraft's systems and serve as a hub for specialized operations and mission planning. It could also double as a meeting room for astronauts to strategize and discuss objectives. Connecting these 6 floors would be a central staircase or elevator system, ensuring a cohesive and functional design. The cylindrical layout would make efficient use of the available space, creating a streamlined and interconnected environment. With a payload compartment measuring approximately 20 meters in height, SpaceX has devised a compact yet comprehensive system. As Starship evolves in future iterations, like the V3 model, its height could extend to 150 meters, with the payload compartment potentially expanding to 70 meters. Such advancements would allow for even greater capacity, accommodating more crew members and systems. The vision of creating a self-contained world within Starship may have seemed like science fiction to previous generations, but with SpaceX's rapid progress, it is becoming an attainable reality. Imagine being part of a community living in such a spacecraft, embarking on journeys to other planets. If given the opportunity, would you seize the chance to live in this extraordinary environment? Share your thoughts and don't forget to like and subscribe to stay updated on SpaceX's groundbreaking developments. Of course, the journey to realizing this vision will require gradual progress, and SpaceX is already making strides in this direction. Right now, inside the new Starship, there is just a simple Pez dispenser and simulated payloads. Perhaps the system and payloads will be gradually upgraded later. While it may not seem directly related to the crew, I believe optimizing these systems will provide valuable experience for building living spaces in the future. In fact, the crew system is already being developed, as shown in the design of the Starship HLS. Last year's update revealed that the HLS has a 2-level configuration. The upper floor includes control systems, crew bunks, life support systems, storage, and more, while the lower floor will house payloads, equipment, dining areas, and training facilities. A staircase in the center connects the 2 floors. This design serves as inspiration for the future crewed Starship version. During the Flight 4 livestream, a glimpse of the Starship HLS's airlock corridor was revealed, showcasing a neat, modern black and white aesthetic. This design could also be applied to the crewed Starship. But rather than discarding such a valuable asset, why not repurpose it as a foundation for a lunar base? One potential idea is to transform Starship into a base. As we know, Starship HLS will bring humans to the moon, and after completing the mission, it'll return the crew to lunar orbit, where they will transfer to Orion for their journey back to Earth. Unfortunately, the HLS will be abandoned afterward. What a missed opportunity, right? We all recognize that establishing a long-term settlement on the moon will require significant effort. If we were to start from scratch, it'd take a great deal of time, effort, and money. So why not repurpose Starship into a base? With a vehicle already designed for crew, it makes sense, perfect sense, if any, to use it for this purpose. Compared to other methods, this approach seems to offer greater potential across the board. The main challenges would involve ensuring enough fuel for HLS to launch and land again, as well as transitioning it from a vertical to a horizontal orientation. But once these hurdles are overcome, we could quickly establish a basic base on the moon, making future landings more efficient. This model could also serve as a blueprint for building the first base on Mars, with Elon Musk and his team leading the charge. Back on Earth, Starship's versatility could also enable it to function as a space station. The idea of a Starship-based space station has been discussed for some time. By removing components like fuel tanks, a single Starship could provide an unprecedented amount of space, surpassing any current or planned station. However, this station wouldn't consist of just one Starship. It'd be a system of interconnected starships, enabling it to support more people, payloads, and systems. This setup would dramatically enhance the efficiency of research and exploration. But in order to realize these transformative systems, SpaceX must first achieve several critical milestones. A top priority for SpaceX is perfecting landing methods for both stages of Starship. While ocean landings have proven successful, reusable systems like Megazilla captures or drone ship recoveries are essential for Starship's long-term goals. Significant progress has been made with Megazilla captures for the Super Heavy booster, but similar success is needed for the ship stage to fully realize Starship's potential. Another critical milestone is developing a reliable in-orbit refueling system, enabling Starship to travel farther and achieve its ambitious objectives. SpaceX has already planned refueling demonstrations, marking an important step toward this capability. Expediting the deployment of specialized Starship variants, such as HLS and the crewed model, is equally crucial. Rigorous test missions will refine their designs and provide valuable data for future upgrades. These efforts, alongside tackling various technical and logistical challenges, will lay the groundwork for Starship's transformative role in space exploration. As SpaceX continues to innovate, the future of space exploration is being redefined within the framework of this remarkable rocket. Starship is poised to create unprecedented systems where humans can live and work comfortably, transforming the spacecraft from a mere vehicle into a dynamic and versatile habitat. These advancements will revolutionize humanity's journey into space, offering a vision of a rocket that does far more than just transport people and goods. Although Starship's development has sparked debates, its extraordinary potential sets it apart from any other rocket system. With the ingenuity of SpaceX's engineers and the visionary leadership driving the project, Starship holds the promise of reshaping humanity's relationship with space. The challenges ahead are formidable, but the possibilities are boundless and undeniably worth pursuing. This has been Kevin with Great SpaceX. Thank you for tuning in, and until next time, keep looking up.